Physics says time can run both ways. So why do we only remember the past? We feel a forward drift because differences relax this way. Yet the deep laws still don't pick a side. So where does the arrow come from? Tonight we keep it simple, soft on the mind, but sharp in the story. Lose detail, gain direction. That trade might be time's quiet trick. Everyday life insists on one direction, and we feel it in our bones. Across kitchens and sidewalks, the drift is steady from neat beginnings toward typical middles. If the laws run both ways, why do we remember only one? Our best microscopic laws do not prefer a side, and that is the quiet surprise. Classical motion can be replayed if speeds are reversed and the steps are followed. Electromagnetic fields allow patterns that run forward and patterns that run backward without panic. Why does light seem to prefer one way? The equations allow waves that spread outward and waves that seem to gather inward from the future. In practice, we meet sources that start quiet, then emit, then cool. That pattern matches outward waves because the messy world around the source soaks up energy and keeps the film running forward. Nothing bans the inward kind because the whole scene around us simply makes them unimaginably fine-tuned. Quantum waves evolved by a rule that works either way when the sign of time is flipped. Direction appears only when heat wanders and when we stop tracking the tiniest collisions. Entropy means the count of microscopic arrangements that share one visible state, and higher entropy means more ways. Think of a glass of water with a quiet cube of ice resting in a patient room. There are many more hidden arrangements for slightly melted water than for a perfect cube with crisp edges. So the ice tends to melt and the glass tends to warm, and the room takes a faint share of that heat. Ice melts but never refreezes on its own in an idle kitchen. Nothing in the fundamental rules forbids a reversal, yet the required coordination is beyond ordinary chance. There are countless ways to look a little melted and very few to look pristine. Lose detail, gain direction. Was that the trade all along? Card shuffle. Picture a clean deck laid in full sequence under a soft lamp. You shuffle once and set it down and glance at the top, and it seems familiar by luck. You shuffle again and again, and the precise starting order becomes less likely with every push of your hands. Keep shuffling, and the chance of returning to the exact order shrinks beyond any practical weight for a human life. Nothing in the rules forbids a perfect return. It is simply swallowed by the count of alternatives. If you care only about broad features like how many reds sit on top, most sequences look the same to sleepy eyes. Typical is what entropy points to when we ignore precise placement. Crowds and the second law. A strange dawn. The arrow we feel likely begins with an improbable beginning. Low entropy at the birth of our universe. A neat start means very few microscopic ways match the early sky. So almost every later step opens into larger sets. From that boundary, mixing, radiation, memory, and even life inherit a tilt toward typical. We do not need a hidden push through time. We need a rare opening scene that makes forward the wide direction and backward the narrow one. The second law of thermodynamics reads like a story told from high in the stands of a late stadium. The crowd spreads toward typical patterns unless a choreographer intervenes with careful cues and timing. Rare reverse formations exist in principle but vanish in practice inside seas of ordinary arrangements. When we step back and keep only the visible shape, the forward drift becomes the rule we expect. The arrow we sense is the direction into the larger set of possibilities. Records and warmth. A record is physical, and making one spends energy and leaks a little heat. That is why memory leans the same way as melting and mixing across our rooms. Think of a photograph saved to a phone and a graphite line pressed into paper at a wooden desk. Energy flows to arrange and protect the marks, and that energy drifts out as warmth into the air. Records of the past gently heat the room that stores them. And that is the friendly cost of remembering. Heat mixing and fragile reversals, a soft mystery that could be true. One possibility is that memory sits at the warm edge of growing correlations. Here is the grounding to keep near your pillow for calm. Making and keeping records requires energy, and that energy finds its way into heat in the surroundings. This aligns the arrow of memory with the same direction as melting and mixing and cooling. Kitchen proofs. Let the kitchen return and watch the steam lift above a fresh mug of coffee on a quiet counter. Heat wanders from hotter to cooler bodies by contact and by soft radiation into the room. Your hand senses a slow fade as energy spreads into more and more microscopic ways to arrange motion. Nothing forbids a tiny gust that might briefly warm the coffee again. It is only far too unlikely to wait for. What we call direction is the near certainty of that spreading when we refuse to chase every micro detail. That forgetting is not laziness, it is survival, and it is designed for thinking creatures. A brain that tracked every molecule in a room would never finish breakfast with any joy. A forecast that traced every molecule would be late by years and useless by arrival to the street. Course descriptions let us predict what matters while they hide the rare reverse paths among mountains of forward paths. With that practical habit, we inherit an arrow without ever naming a pushing force behind our backs. Scent and tea. Bring the stove and pan into view and watch a ritual of heat and patience and sound. Oil spreads like a sheet in onions, soften and sweeten, and the kitchen air learns their story. Close the window and the scent lingers because the room holds many ways to keep it and very few to undo it. Open the window and the scent thins into the night, which offers many more paths for the tiny motions. Think of sugar stirred into tea and the slow loss of the graceful white cloud in a deep amber cup. At first, the swirls look special, and you can trace curves with your eyes as if they were handwriting. Soon the tea is uniform, and a calm sameness fills the cup and the story leans one way. You could imagine reversing every tiny eddy to draw the sugar back, but the needed coincidences outrun any patient evening. The rules would allow it if arranged, yet the odds decide what we meet. Noise and chords. We can read the same lesson in sound without touching a single control in the room. A choir singing a clean chord is special and low in the space of possible wave patterns in the hall. Rain or applause fills that space with many more patterns that feel alike to a drowsy ear. To unscramble applause into a chord, you would need pushes from walls and people in air that almost never align. The rules do not ban it, but the odds do, and the odds win in ordinary life. Bits and warmth. Information rides on physical marks and stubborn differences held against noise. To store a bit, you tilt a small device toward one of two options, and you keep it there with care. To erase a bit, you give up that difference, and the device shares a breath of heat with its neighbors. There is a minimum heat cost to erasing information at a given temperature, and that cost is paid somewhere nearby. Memory and warmth travel together, and that companionship points in the same direction as melting and mixing. Keep claims small and calm. We should keep our language careful because time invites big stories when small stories already explain a lot. Entropic time is an emergent description for complex systems and for the way we describe them in broad strokes. It sits beside the time of relativity, which governs motion and gravity, and beside clocks that ride beams and orbits. It does not settle questions about choice or meaning, or what you will do tomorrow after tea. It helps with kitchens and cards and cups, and with the sense of drift that follows from counting possibilities. Why do we remember one way? We remember one way for plain reasons. Because remembering takes work, and work gives heat to the room, and the room takes it gladly. Because forgetting details opens the wide roads and closes the narrow alleys that might have led back. Because we live on the large scale where the many beats the few almost every time we look. Because the arithmetic of ways leans forward when we stop obsessing over perfect control of every speck. Home checks of the arrow. Sweep the house with your eyes and find small proofs of this gentle tilt that guides us. Warm socks leave the drying rack and greet a cooler room, and the room grows kinder to bare feet. A cube tray returns to the freezer, and the cold engine does paid work to push heat uphill. Where paid work appears, the arrow can locally reverse. But the total bill shows the world still gains ways. Devices buy small islands of order by spending energy that turns into wider seas of disorder around them. A tidy drawer stays tidy only by maintenance, which is work, and work must come from a source that can be warmed. Left alone, the drawer drifts toward a typical look with socks and scarves sharing space in friendly confusion. The rules again do not ban a miracle of spontaneous tidying. They simply allow far more ways to be mixed. This is the quiet fairness of statistics that governs without a badge and guides without a threat in sight. We call that guidance an arrow because it points where options multiply and where sameness grows from difference. Kitchen clocks. You can almost tell time from the way heat settles between things that touch and share. Place a warm spoon in a cool bowl and feel the tiny ticks as warmth flows from one to the other. Each little exchange is a step toward a common temperature, and the steps have a rhythm set by contact and surface and air. If you look only at this small system, the march is one way, yet nothing in the micro rules forbids a brief step back. What forbids a lasting reversal is the arithmetic that counts more blended states than separated ones at our scale. Call this a kitchen clock that needs no hands, only a gradient and time to even out. Clocks without hands. When two parts exchange heat, their tiny correlations grow and fade in steps like quiet ticks. Each tick is a small update, less difference, and more shared story. If you watch only this pair, the march feels one way because there are many more blended patterns than split ones. Some physicists speak of time as what tracks these changes in relations, not a river by itself. We can hold that gently. Warmth and correlation can read like minutes in simple rooms. Two kitchens story. Imagine two identical kitchens at dusk with matching mugs and matching windows and the same outside weather. In the first kitchen, a kettle just boiled and a window is closed and steam writes soft trails on glass. In the second kitchen, a kettle is cold and the window is cracked and the air feels brisk and dry. Walk into each room with eyes closed, and you could still guess which way the arrow points by touch and smell alone. Warmth spreads until both rooms feel ordinary, and that ordinary feel is a sign that many arrangements look the same to us. Fragile reversals. Tiny reverse flickers happen all the time in small patches and for short breaths. A few molecules bump and rewarm a corner of coffee for an instant, and then the corner gives it back and the trend resumes. We miss these flickers because we watch with coarse eyes and average across billions upon billions of collisions. The arrow we speak about is not a ban. It is a near certainty born from large numbers. That is why the film of life runs one way, even though single frames could in principle be reordered without breaking laws. Local reversals bought with work. A freezer makes ice by doing paid work and dumping heat into the room behind its back. An air conditioner cools a bedroom by pushing heat out the window and warming the alley outside. A heat pump can move warmth from cold air into a house because it spends energy to climb the hill. These devices make tidy corners inside wider seas of disorder, and the total sea still grows in its number of ways. Order is local and rented, the rent is energy, and the landlord is the surrounding world that takes the heat. Signal and noise at home. A faint radio station can be recovered with a clean antenna and a quiet amplifier when the house is still. But the amplifier and the algorithm that sharpens the sound both warm the room a little as they work. To rebuild signal, you must spend energy, and that energy returns as heat. So the neighborhood of air gains possibilities. Clarity takes work, and work has a thermal shadow. That is why tidying sound, or images, fits the same arrow. When we accept this, we stop asking for miracles and start paying the fair price of order, the movie test. Watch a short film of an egg cracking on a pan and decide whether it runs forward or backward. You can tell because splashes spread and shells fragment and steam rises, and none of those are likely to reverse together. Now watch a pendulum swing and a planet revolve in a dark simulation and ask the same question again. Here the guess is harder because those motions are close to time symmetric at the level we see. When heat and mixing enter, direction becomes obvious, and when they step out, our sense of flow calms down. Error correction has a cost. Your phone protects photos against random flips by adding extra check bits that let it detect and fix mistakes. Creating and using those checks takes energy, and that energy leaves as warmth into your pocket and into the room. The more stubborn you want the memory to be, the more energy you spend over time to keep noise at bay. In this way, information is braided to thermodynamics, and the braid lies in simple places like chargers and desks. Records endure by paying small rents to disorder, and the rents add up to the arrow we notice each day. Granularity in maps. A map of your block leaves out almost everything, and yet it helps you walk without confusion. A more detailed map might add every tree and stone, and still, you would not reach the list of molecules. When we choose a level of detail, we also choose which reversals are visible and which vanish into noise. Coarse graining is this choice made on purpose, and it is why a direction appears when we talk in macrostates. The map is not the territory, yet a useful map gives the same arrow you would feel with your hand on the street. 3 boxes and a window. Open a small door between 2 gas boxes. The fuller side empties, the emptier fills. Add a 3rd box and open both doors. The middle settles between neighbors. If you track every molecule, you can invent paths that flow back, but almost all coarse views look the same at the end, even spread. Coarse graining is just this. Keep the visible shape and forget the atomic diary. Forget a little. Find a line. Heat paths in small things. Take 2 metal spoons, one warm and one cool, and touch their tips together and wait in quiet. The warmth divides until neither spoon remembers which one began above room temperature. This forgetting is not sadness. It is the natural result of many micro possibilities swapping energy back and forth. You could separate them fast and reclaim a little of the difference, but you will spend energy arranging the trip. Small rescues are possible. Global rescues are expensive, and the sum of costs keeps the arrow true. Why do illusions not break the rule? A clever fan can reverse a paper streamer and make it curl toward a heat source in a surprising way. A thermal diode can channel flow more easily one way than the other in a carefully built material. These scenes look like escapes, yet they spend asymmetry or structure that took work to set up in advance. The second law keeps its calm because the count of global possibilities still rises when the whole scene is included. An arrow that bends locally has a wider ocean that grows anyway, and that growth is what we measure. Habits for clear thinking. When you feel time rush, ask whether heat moved and whether details were averaged out. When you wonder about miracles, ask who paid the bill and where the warmth went when order improved. When you see a tidy island, look for the engine that keeps it tidy in the place that engine warms. When you think of memory, picture the small lift in temperature that attends every saved mark and lesson. These habits turn awe into agency without breaking the spell of night. A bedtime test. Close your eyes and picture the kitchen at noon with sunlight on a glass of water and a single cube. Let time move and the cube softens and the water calms and the glass fogs and clears in easier breaths. Now try to run the scene backward and watch how many special coincidences you must invent for the cube to return. Your mind feels the uphill, because uphill is narrow and downhill is wide, and the width is what we count. At heart, the trade is simple. Fewer details give a clearer direction. It does not require a hidden force that pushes moments from past to future like pages caught by wind. It requires only that we talk about shapes rather than grains, and about warmth rather than every darting hit. When we speak that language, the arrow appears as naturally as a shadow beside a candle in a quiet room. We are not fooled by a trick. We are choosing the level where the pattern makes sense at human pace. What if memory is just the warm edge of growing correlations? We can hold that thought lightly without grand claims about minds or fate or hidden scripts. The comfort is that our records and our warmth and our sense of drift share the same quiet arithmetic. It is the counting of ways that guides the scenes of kitchens and cards and notebooks. A calm promise. We kept kitchens and cards tonight. Tomorrow we lift our eyes, a rare beginning for the whole sky, why good clocks can be trusted, and how memory fits without grand claims. So the arrow we feel begins as a quiet statistical bias, seated by a strange low entropy dawn. From that bias flow our memories, our clocks, and the very shape we call now. The kitchen fades and the sky arrives with a quiet precision. We follow the arrow outward to the largest stage where beginnings matter most. We keep the tone soft and the claim small while the scale grows. What felt household-sized? Will it take on cosmic light? A wider past hypothesis. Low entropy at the beginning is a boundary rather than a mechanism. It says the early universe occupied a rare corner of possibility where smoothness was special for gravity. Smooth means matter spread almost evenly, while gravity prefers clumps and curves and crowded centers. From such a neat start, the number of accessible arrangements could swell as matter gathered and stars ignited. Galaxies formed and black holes opened vast new catalogs of ways the world could be. Locally, we harvest the contrast between hot stars and cold space, and life rides that contrast like a tide. No new law was added, only a starting page that makes forward the wide direction and backward the narrow one. Seen this way, the arrow is not a push, but a permission written at the dawn, on smoothness and clumping. Imagine a nearly uniform fog of matter in a dark room that feels almost the same everywhere. Tiny ripples appear, and gravity pulls a little extra toward a little extra, which makes the ripples grow. Over a long time, the fog breaks into stars and clouds, and then into galaxies and clusters. Each new clump opens more ways for motion and light to arrange and disperse. The quiet beginning lets structure bloom, and the bloom lifts the count of possibilities by deep steps. In this story, the past is narrow because it began near uniform, while the future is wide because structure can grow. The direction you feel is the slope from rare neatness to common variety. Speculation held gently. One possibility is that a very early process stretched small regions into smooth patches before stars were born. We keep this as a maybe because it sketches a path to uniform calm without proving why that calm happened. The grounding is that the early sky was very smooth with tiny ripples that later grew. That is enough to seed the arrow we live with and to feed the stories of mixing and memory. We can rest without forcing a final answer to why the first page was tidy. Cosmic bookkeeping. Think of the cosmos as a very large ledger that records contrasts paid in and paid out. Stars pay light into space. Planets pay infrared warmth back to night. Black holes pay entropy into hidden interiors. Local order is written by spending gradients, and gradients are replenished by the unevenness seated at the start. As the ledger grows, the sum of ways increases, and our diaries of change lean the same way the ledger leans. This is a calm picture, not a final theory, and it fits the scenes beyond our windows. Records in a large world. A footprint on a beach persists, because wind and waves erase detail, while keeping a broad mark readable for a time. A crater on a quiet moon persists for ages because nothing stirs to smooth it out. A dusty ring around a planet holds patterns because countless grains share pushes and settle into typical curves. These traces point back because the acts that made them sent energy away into many channels that will not rewind together. Memory scales from notebooks to beaches to orbits because record-making spreads warmth and correlation outward. The arrow of remembering inherits the same tilt as the arrow of mixing under a wide sky. Decoherence at eye level. A small system that can be in several delicate conditions interacts with air and light and the table that holds it. That interaction ties the system to many neighbors and makes some outcomes stable and easy to read later. The tying is one-sided at our scale because the neighbors are many and their motions disperse any fine-tuning we try. The result is a record that points toward the act that created it rather than away from it. We call this decoherence, and meet it whenever a delicate choice leaves a sturdy trace in a warm world. The trace aligns with the big arrow because the tying added to the count of ways the neighbors can be. Clocks without hands. Consider two small parts that exchange heat through a thin bridge and share nothing else with the room. At first they differ, and then their difference declines in a steady dance of tiny exchanges. If you watch only their relation, the decline reads like time because it orders events by how far the difference has faded. Another watcher could choose a different relation and count steps in another way and still find a steady march. Once the room is allowed to talk to the pair, the many exchanges bring most counts into broad agreement. So time can be read from change in relations when heat is the book that tells the story line by line. Relativity beside the hearth. You can carry a precise clock on a long flight and bring it back a tiny bit out of sync with its twin. You can set a clock on a mountain and another at sea level and watch them drift apart by a measured amount. These drifts arise from geometry and speed and the curve of space and time around mass. The entropic arrow does not alter those rates. It rides on top of them. Wherever heat spreads and details blur, the same direction returns, even as local rates vary with height and motion. Two truths sit together, one about how fast clocks run, and one about which way most stories lean. Why outward waves win. Equations for fields allow patterns that move outward from a source, and patterns that converge inward toward a source. We mostly meet the outward kind because sources begin near quiet and then shed energy into the world. The world around them is busy and absorbing, and it carries that energy away into many places at once. To build a converging pattern, you would need the world to prepare a very special incoming dance in advance. The rules do not forbid that dance. The world does not rehearse it by accident for us. In this way, the same tilt that guides kitchens makes radiation look one way from our balcony. A corridor of gradients. Starlight arrives hot and sharp while the night is cool and wide, and that difference is a corridor you can walk down. Plants turn light into stored order and later release warmth and soft light back to the sky. Engines eat fuel and give motion and sound to wheels while their exhaust warms air and stone. People learn songs and build cities and write ideas and pay with a little warmth to the room as they go. All through the corridor, the total count of ways expands while islands of order rise and fall for a while. The arrow is the hallway itself, not the steps you choose along it. Biology along the corridor. Cells maintain order by spending energy on pumps and repairs while shedding heat into their surroundings. Metabolism is a steady exchange where gradients are consumed and structure is kept for a time. Learning lays down biochemical marks, and those marks cost energy to form and to keep against noise. Life is not a violation of the arrow, but a dance within it, graceful because it pays its way. The dance continues as long as gradients are available and ends when the corridor flattens. A gentler free choice. We choose which differences to keep and which to let go, and that choice shapes the stories that follow. You can chill a drink with ice or with a machine or with a cold night breeze, and each has a distinct thermal bill. You can store a photo in cloud memory or on a paper print, and each has a different cost in warmth over time. These are small freedoms that work within the arrow rather than against it. Seeing the arrow as a partner turns worry into design and design into calm. The night quiets when we pay fair prices for the order we ask to keep. Examples at scale. Rivers smooth sharp bends and carve broad plains, while snow on high mountains packs into ice that flows to the sea. Storms mix air masses and then fade as more uniform air returns, and the heat they moved spreads into the night. Volcanoes raise islands of new rock, which wind and water grind into sand that joins the old sea floor. Forests grow from seeds in ash and thrive on gradients of water and light and soil, then share their stored warmth back. In each case, the large pattern leans toward typical, while local detail blooms and fades in cycles. You feel time here as the steady slope from sharp to smooth, while life sketches on the slope. A page on black holes. Among all clumps made by gravity, some are so deep that even light cannot climb out once it steps too near. These deep wells are special because they hold an enormous number of internal arrangements hidden behind a simple surface. That is why they are counted as large contributors to the grand tally of ways the world can be. From a tidy dawn to a sky with these deep wells, the number of possibilities has risen by amounts beyond easy speech. In that rise, the arrow finds a clear and quiet confirmation across wide scales. We can rest with that thought without chasing any horizon tonight. Thermal time as a lens. Some thinkers suggest that time is not a universal river, but a way to read change from how a system shares energy. Pick a complex system and ask which relations define its state. And then ask how those relations evolve when heat can move. The count of changes becomes a kind of internal time that depends on what you chose to watch. Two watchers could define different internal ticks and still agree on the main direction once a larger world is included. This lens does not erase geometry or proper duration. It adds a way to talk about direction in warm places. Held gently, it turns abstraction into a simple reading of ongoing exchange. Correlations as a metronome. In a small closed world, two parts can begin unlinked and grow linked through simple interactions. If you ask only about their linkage, you can use that growth as a count for a while. When the linkage saturates, your count ceases to tick and another count may take over. Open the world to a wider room, and new linkages appear and fade, and the march resumes in a broader key. This is a gentle picture of time, as the growth of shared stories between parts of a world. It keeps company with warmth because both speak about how differences relax. Light cones and diaries. Relativity sketches a map that limits which events can touch which others by signals that travel no faster than light. Within that map, our diaries of change still lean the same way when measured in kitchens or in orbits. Two observers may slice the map into nows in different ways and yet agree on which processes run, typically forward. The lean is robust because its source is in counting possibilities rather than in naming present moments. This is how emergent arrows and geometric time share the same stage without conflict. The play runs smoothly because each reads a different line of the same script. A quiet rebuttal to worries. If direction is emergent, does that make choice an illusion? No, it makes choice a way to spend differences on futures we prefer while paying fair heat to the room. If now is just the edge of growing correlations, does that empty now of meaning? No, it makes now the working face where new records are carved and old records are read with care. These answers are gentle because the puzzle is gentle when framed in small, honest steps. Calm comes from clear framing, not from grand promises. An everyday experiment in patience. Place a cold spoon across the rim of a steaming cup and watch fog gather and retreat in slow rhythm. A tiny microclimate forms at the metal and then dissolves back into the room as the counts rebalance. Move the spoon and the rhythm changes because the local corridor for flow has changed shape. Here is a clock made of exchange and a lesson about how small choices shape local arrows without touching the grand one. Keep the lesson and leave the cup to cool while you breathe. The night continues to make sense at a human pace. A page from the background light. All across the sky there is a faint afterglow that carries a map of tiny early ripples. That afterglow is a broad record because light from that age has stretched and cooled while crossing a growing space. Its near uniformity tells us the early world was very smooth, and its small bumps match seeds that later grew. Reading that map is like reading tree rings for the cosmos, wide calm with fine structure ready to blossom. From smoothness to clumping the count of ways rises, and the map explains why forward feels wide. Entropy and light. Light from a hot surface carries order that can do work when it meets cooler matter. As that light is absorbed and re-emitted at lower energy, it spreads across more modes and directions. The spread increases the number of accessible arrangements, while local pockets borrow neatness for a while. This is why engines run between hot and cold, and why planets glow softly after bathing in starlight. The arrow in radiation is the path from focused high energy to diffuse low energy shared with many neighbors. Radio at the window. A small antenna can send a wave that carries a pattern outward into the street and into the night air. To receive the exact reverse, you would need the whole neighborhood to conspire to drive energy inward in perfect step. The rules allow this in principle, but everyday rooms do not arrange such precise convergence by chance. So we mostly send and then watch the pattern fade as it shares itself with walls and trees in the sky. That fade is the same tilt we met in coffee and cards, only now it rides on fields in open air. Gravity and warm halos. When gas falls into a galaxy halo, it heats as it loses height in the gravity well, and collides with itself. Some of that heat radiates into space, and some stays to keep the gas puffy and resistant to further collapse. Stars form where cooling winds for a while, then feedback from young stars, and black holes warms the halo again. The cycle writes a long story of gradients, spent and replenished, that lifts the total count of ways step by step. Galaxies are not against the arrow. They are engines that run on the slope from neat to typical, a trio of linked cups. Place 3 cups with warm water in one, cool in another, and lukewarm in the middle, linked by thin metal spoons. Heat walks along the spoons, and the middle cup first moves toward one neighbor, then toward the other in a gentle sequence. If you watch only the middle cup, the changes arrive like ticks as differences shrink in orderly steps. If you watch the pairwise relations, you can count another steady sequence that agrees in broad outline. Here time is read from correlation changes, and the reading is stable because many spreads are possible, but few reversals are. Arrows in the plural. There is an arrow in mixing, an arrow in radiation, an arrow in memory, and an arrow in gravitating structure. They look different in detail, and yet they rhyme because they all spin differences into wider possibility. The rhyme comes from the same early rarity that left room for many futures and few pasts. Seeing the family likeness prevents confusion and keeps the story calm and consistent. Macro awe held softly. Stand outside and lift your eyes to a dark band of stars arching above the roof lines of your street. Picture how many ways all this matter could be instead of the graceful sweep. Then fold your attention back to the early sky when almost every place looked the same to a fine degree. Feel the slope from rare tidy to common varied, and let that slope explain the sense of flow you carry. In that feeling, the arrow becomes a comfort instead of a command. The comfort is earned by counting and by patience rather than by mystery. Cosmic humility. We might dream about deeper reasons for the neat beginning, and we are allowed to wonder. But tonight, we keep the wonder gentle and remember that a boundary condition can guide without a visible gear. The evidence for a smooth early sky and a rising count of ways is strong and restful to hold. We can keep curiosity for daylight and let calm have the night. A few closing clarities. This account is emergent and sits beside accounts that speak to rates and geometry. It does not deny deep equations that work both ways in time. It explains why coarse views lean one way. It does not claim that minds cause arrows. It notes that record making warms rooms and ties stories together. It does not require fate. It invites agency within honest costs. That is a quiet way to walk through large questions at night. A last household image. Set a cup of water on a sill and place a small cube of ice upon a spoon beside it. Watch the ice in the room become a memory, and the water by the window hold a small coolness a little longer. The two scenes share a theme. Differences fade, and the world learns a new typical shape. The Diary of Atoms would show reversible steps. The story we tell shows an arrow that helps us rest. Sleep comes easier when direction is friendly, not frightening, an open question for the morning. If time is the growth of relations, what new relations will you cultivate when the sun returns? You will spend warmth to write them, and the room will accept your payment with quiet grace. The bill will be modest, and the memories will be warm. That is a good bargain for a small life under a wide sky.